Here, I thought I was all good and on time and was trying to send a quick email, and then the room's locked, so I have to get the passcode, which means I have to get duoed and go through that whole process. All right, so let's do this. So we had a few slides from last time that we didn't quite get to finish, so I want to finish those ones up. Then we'll go to, oh my God, I never did push. I was thinking that. Now I messed this up too. Let's just chat for a little bit. So how's everybody doing? Great, yes. 10 a.m. computer science, there's nothing like it. So I updated some things, and I was thinking this morning, I'm like, did I ever push? And apparently I did not. Yeah, I definitely didn't. I didn't push the changes. So I'll push. Yes, I actually want to push. Stop asking me. And we'll talk about files first. So last time we talked about encodings and how we have to make sure that the content length is always in bytes. That's the most important thing to remember with content length. So when you have strings, some characters, a lot of characters are going to be a single byte, and that's fine. You can just take the length of the string, but you won't always get away with that. So realistically, we should never do that. We're always going to take the length in bytes. So you have to encode the string using typically UTF-8, and then take the length of that byte array to get the number of bytes. Oops. Then I clicked the wrong slide. I swear to God, come on. Oh, I'm still clicking the wrong slide. I got this. So we have dark mode slides. That's what I want. I didn't do all that to not have dark mode slides today. All right. So we know how to send strings. We're going to encode them using UTF-8, take the length in bytes, and then send that. In Python, this means that we have to encode first, that dot encode. That's going to convert your string into a byte array, get the length of that, len, length of that thing, and then that's your content length. In JavaScript, if you're using JavaScript, use buffer.from. That's going to convert your string to bytes. And then take the length of that, dot length, to get the content length. JavaScript, if you send a string over your TCP socket, it'll automatically convert to a byte array for you. So you do have to add that extra step of actually explicitly converting to a byte array and then sending. So you need to convert to a byte array, then compute the content length, and then send that over the internet. So content length is always the number of bytes. But what about non-text data? So what if we don't have text and we don't have this UTF-8 encodings or ASCII encodings? What do we do for that? This is where we left off last time. So objective 3 on the homework, we're up to objective 3 with these couple of slides. Objective 3, not really that bad. One little caveat to it, but not too bad. Assuming you can complete objectives 1 and 2, objective 3 should be fairly free. And then 4 and 5, there's a pretty big jump up in difficulty, which we need to spend the next 5 lectures talking about. So be ready for 4 and 5. But after today, if I were you, I would be getting up to objective 3 done after today, and then be ready for objectives 4 and 5 going into Friday's lecture. So for objective 3, we have to send images. 1, we have to read the path that's being requested. Before, we could just say if path equal slash hello, do this. If equal slash hi, do this, etc. Now we have to check just a little bit of extra. If path starts with slash image, then separate on slashes, get the file name that's being requested, and then open up that file. So we got a little bit extra with the pathing. But then what do we do with this file? Once we open the file and we want to send it in an HTTP response, which we've only talked about text so far, how do we send that? And that text can be HTML, can be CSS, can be JavaScript. Actually, worth mentioning, your HTML, CSS, and JavaScript, you're not really sending them as files. You're just sending them as bytes. So you are sending a file, but you're only sending the contents of that file in the body of an HTTP response. That's how we send files. Files are just bytes that are saved to disks. So we're taking those bytes, sending them, and then on the other end, the browser is going to take those bytes and save them in a file with the appropriate file name. There's no magic with files. Everything's just bytes. So we're going to send the bytes. So for an image, we're going to read the image from a file. That file is a bunch of bytes. And that's the body of our HTTP response. That's it. Don't overthink files. Just read the file and send those bytes. That's it. The file for an image is already encoded, in our case, using the JPEG encoding. You don't have to do anything with JPEG. You don't have to know anything about the encoding. You just have to read the file. This file has the bytes that I need. That's the body of my response. The length of that byte array when you read the file is going to be the content length. The content type is going to be image, for our purposes, image/JPEG. And then send that to the browser, and the browser is going to know what to do with it from there. We don't have to do anything else. Don't overthink sending images. The one thing to really remember is make sure you're opening the file in byte mode. Don't open the file as a string. Quite possibly, anytime you open a file, up until now, you've always wanted to read it as a string. If you're opening a text file, a CSV file, a JSON file, you always want to read that as a string. So you open it, you decode it as UTF-8, and then you read the contents of that string. With an image, those bytes are not encoded as UTF-8. So with UTF-8, we had this specific format, and we had to follow this format for encoding text in UTF-8. Your JPEG images will not follow this format at all. So your JPEG, it's going to follow a different format. The bytes are going to be structured differently. And if you try to decode an image using UTF-8 encoding, the bytes will not follow this convention, and you're going to get a decoding error. It won't just decode to the wrong thing. It won't decode at all. And depending on your language, it might just guess and give you the wrong thing. But you can't decode an image using UTF-8 because you're not going to have, you're going to have some bytes that start with 1, 1, 0, then a bunch of ones and zeros, and then the next byte won't start with 1, 0. So you're going to get a decoding error because it doesn't follow UTF-8 convention. So it will break. It will corrupt the image. We can never convert an image to a string. Never, never, never. Can't send an image as a string. You can never convert an image as a string because it will corrupt the image. You won't have the right bytes. So for example, if you take the bytes for an image, decode it as UTF-8 into a string, and then encode it again into bytes, you will not have the same bytes that you started with. It will not be the same data because it's not valid UTF-8. So the most important thing, and this will come up in homework 1 and homework 2, this will be very important. Your images, never, ever, ever treat them as strings. Never convert them to a string, or your image is going to be destroyed. It's going to get corrupted, and you're not going to be able to send the right data. So with an image, read it as bytes. It's already in bytes because it's a file. Get the length of those bytes for your content length, and then append those bytes to the end of your HTTP response after that blank line, after that CRLF. So when you concatenate those, the next thing to think about is we have to concatenate that onto the end of our response after converting the headers into bytes. So if this is Python, we're going to formulate our response. We're going to read the file, get the content length, build all our headers, build our response line with the 200 OK, and the CRLF at the end. Encode that into bytes, and then take the bytes of our image and concatenate that right to the end of it. We can't add the bytes of the image to our response until all the text of our response, all the headers, are already encoded in bytes. In JavaScript, this is buffer.from, convert that to bytes, and then concatenate it with buffer.concat to your image. Add your image to the end of that. But that all has to be done in the world of bytes. So this is the one big caveat with images. We have to work in the world of bytes. We cannot work in the world of strings. We cannot use string concatenation with these bytes because these bytes are not UTF-8 encoded. Don't overthink. I already said it once, but don't overthink this. The big thing, just making sure you're working in the world of bytes. Other than that, don't do too much with the image. You're reading the file and slapping it on your, as the body of your response. Yeah, so videos are the same. In any image format you have, any video, really any content, any multimedia content that you have, unless you're actually doing something with the file formats, if you want to mess around with like converting JPEGs to PNGs or something, unless you're doing something like that, you really don't care what that data is. You're just taking the bytes, you care that it's a byte array, and then you send the user those bytes. Let the browser handle whatever format it is. The browser will say, oh, these bytes are MP4 encoded because your content type is video/MP4. And then the browser will take care of it from there. We don't care what those bytes are. We just send the bytes. Open up the file, send the bytes. They're unofficial until you say otherwise. Priest, bless my slides, please. So images are not broken up into binaries. I'm not quite sure what you mean by that. So the images are a byte array. The file is, every file is an array of bytes. If it's text, it's UTF-8 encoded. If it's a file like JPEG has a very specific structure to it where the bytes, the order of the bytes mean very specific things. I'm not familiar with the JPEG file format, but like the first couple of bytes will have some meta information, and then you'll get into the data for the pixels of the image. And JPEG is a compressed algorithm, so there's, when you read a JPEG file, to actually interpret those bytes, you'll read the metadata, run your decompression algorithm to get the pixels, the RGB values for the pixels, and then render that image to the screen. But to us, it's just a bunch of bytes. And then whatever program is going to open or browser is going to open that image and render it, they're going to have to speak that encoding. So it's not a binary, what was the question, broken up into binaries? Like it is a binary file. It's just a bunch of ones and zeros, just like everything in the computer. That's following a very specific format, which for our purposes, we specify by the MIME type in the content type. We say, hey, this is a PNG. Then the browser knows to use the PNG algorithm or protocol to be able to interpret those bytes. So it is a binary. It's not an executable binary, if that's what you're saying by that. Yeah, yes, Nicholas. So there is base 64. You could base 64 encode things. That's a way that you can represent arbitrary bytes as strings, which will come up briefly later in the course. Can we send a JSON over a response? Yeah, you can send anything you want over a response. Think of anything you've ever accessed on the internet. That was all sent in HTTP responses. Everything on the internet is sent over an HTTP response. It's a little bit of an overstatement, but not too much of an overstatement. I will say everything you've ever accessed on the internet has been sent over using bytes, using just ones and zeros over wires and fiber and Wi-Fi. Everything is encoded in ones and zeros on a computer. So yeah, absolutely, you can send a JSON. And objectives 4 and 5 have you doing that. With JSON, the body is just a string that happens to be encoded happens to follow the JSON structure. Oh my goodness. I was off by one there. I have another presentation going. I hate when I do that. I've done that twice already now. But let's get this out of the way before we get into Docker. Yeah, Toadfish, I always know the problem you have with your images. At this point, I've taught this class enough times, I know what all the common problems are, and I make sure I hit them in the slides, and now I'm hitting them in lecture questions, making sure you're aware of all the common mistakes. And hopefully nobody makes the common mistakes. Yeah, I don't recommend using text-to-speech on an image. I haven't done lecture questions in a long time, at least, but I'm liking my ability to really emphasize the most important point of each lecture. All right, everyone good? Everyone submit? No? Okay. Duo. I know, that's why lecture was a minute late. Freaking Duo. Well, I had like 3 different problems there. This is the first day the room was locked when I got in. I didn't notice it. And then I got duoed. And Wi-Fi problems? No. And I'm going to assume anyone who's still answering at least knows what they're going to input. So I'm going to start setting up the next slides. And we'll start talking about Docker. Any other questions about files, strings, bytes, content length? So we're going to shift gears quite a bit into some DevOps topics, which might be a term most of you haven't heard, actually, now that I think about it. DevOps is anything, like once you're done with your app, the DevOps team is going to take control of it, and they're the ones who are going to manage the deployment, the actual running code that's live for users. Once it enters that territory and is actually deployed to live users, we put that under the DevOps umbrella. All right, I assume everyone's good on the lecture question. So a little bit of vocab on that. We have 2 different environments that we talk about, probably in all development, but at least in web development, I know for sure. We'll talk about these 2 developments, dev and prod, or development and production. We usually call them dev and prod, though. Dev is going to be your environment where you're actually writing your app. This is typically your laptop, your desktop, wherever you're actually working. That's your development environment. You set up your IDEs, you set up Docker, as we're going to see today. You set everything up locally and run your code, fix your bugs, write your code, all that good stuff. That's where we all live most of the time when we're dealing with software. We're going to live in dev. Production is when your app is actually deployed to live users. It's sitting on a server. It's running 24/7. People are visiting your app, using your features. That's going to be the production environment, which is typically a different machine. You're going to have some server and a server rack and a server room somewhere, and that's going to be running your app in production. 2 different environments, 2 completely different machines. And dev, if you're working on a team, you're going to have a lot of different dev environments, and then 1 production environment for that actual server. So we have the standard headache. And I guess at this point in your careers, you can think of Autolab as production. Does it run in production? Well, it worked on my laptop. I submitted to Autolab, and Autolab said it didn't work. That's a dev versus production issue. It worked on my laptop. It worked locally. But once you go to production, you go to deploy to users, everything's broken. It's a big headache. It's frustrating. It sucks. We all hate it. It's a big pain to deal with this kind of stuff. And there are lots of reasons that you can have this kind of error. Lots of very legitimate reasons. Lots of very tricky to find reasons, too. any version differences, any environment variables that aren't set the same across the environments. Hard-coded paths. I just ran into this one fairly recently. I had code where somebody put hard-coded localhost into their server, and then you go to deploy. Well, when you deploy, it's not localhost, it's whatever your domain name is. So you got to get the host dynamically. Things like that can happen quite often. So a solution to this is to use virtual machines. Something you've probably heard of before, I assume. I think you use these in 220, 250. I don't know. You've seen these before, I'm sure. If not, a virtual machine is a simulation of an entire operating system and an entire machine, which we can run on our machine. So I can have like 2 different operating systems. If I want to run Windows on my Mac, I can run up, install VirtualBox, spin up a VM, a Windows VM, and then have Windows alongside my OS X install. If we use virtual machines, we can alleviate a lot of the problems that we have with deployment. If we use a virtual machine in our dev environment, and then in production, we use that same exact virtual machine, same exact environment variables, same exact versions of all the software, everything exactly as it appears in development. So we don't actually run it on our dev hardware. We don't actually run anything on our prod hardware. We run a virtual machine in either of them and run the same exact virtual machine. And it eliminates so many headaches and so many problems. It all but gets rid of that. It worked on my laptop issue. If you're testing in your virtual environment, it's the same exact environment as production. What could go wrong? The previous thing I just mentioned, you might have a hard-coded localhost. You might have things like that that can still go wrong, sure. But it alleviates a lot of the issues, a lot of the surprise issues especially, where you're running a different version of Python. It's 3.8 versus 3.9, and some features exist here or not there. You don't have that kind of issue. We're using a different version of the compiler in C or something like that. We also have some security gains from this. If we run our code in production inside a VM, now say an attacker finds an exploit, hacks our code, gains access to the server, and starts breaking things, starts stealing information. Obviously, all bad. These are things that we want to avoid. We'll talk about this throughout the semester as security topics come up. But if they're in a VM, we at least have one layer of security. If they completely ravage that VM, they didn't actually break our server box itself, our actual hardware, our actual machine. They can't touch that. So when we have a compromised VM, just delete that VM, patch the bug, fix all your security issues, and then spin up a new VM, create a new VM with your app running on it, and you're up and running again. You're back running. You don't have to actually go in here and fix whatever damage the attacker caused. Just wipe it out, create a new one. Basically doing a fresh install on your machine, but instead we're just doing it as a VM. We just delete the VM, copy it back in, a fresh one from dev, done. So there's a limit to the damage that they can cause. And there are a lot of apps. So one attack is, I forgot what we call it in this world. Arbitrary code execution is what I've been calling it. Code injection. Code injection attacks is where you can, arbitrary code execution is what speedrunners call it. I've been watching speedruns. But code injection attacks where you can inject code into a server and have the attacker's code run on the server, which is bad. Once an attacker can run their code on your server, you're in trouble. They have a lot of access. They can write code that just does anything, reads your files, changes your files, reads your databases. It's bad news once they can do that. However, there are apps that have to do this. This is how Autolab works. You submit code. Autolab's purpose in life is to accept code injection attacks, run that code, and then give some information about that code. AWS, Heroku, DigitalOcean, any of these cloud platforms, cloud services, they all have to accept code and run that code. So how can they do this securely without just destroying everything? Well, we run your code inside a virtual machine. We run it in a VM. For Autolab, if you ever wonder why Autolab kind of It has some overhead. When you submit, it takes like 10 seconds to load before it loads up that page, and then you have to refresh quite a few times. It's because it's spinning up. I'll start talking about containers soon. Containers are basically VMs. It spins up a whole new container, puts your code in there, grades it, and then destroys that container. So even if in your code you make a syscall to rm/rf/, which removes all the everything and just destroys a Linux installation, absolutely destroys everything. Even if you do that, it's no big deal. We're just going to delete that container anyway. We're done with it, and then we spin up another one. So you can imagine this takes a little bit of time. The Autolab server has a lot of power behind it. It's a very beefy server. It's actually a cluster of 6 really beefy servers. So it doesn't take super long to spin up these containers. But it's still a lot of overhead. No matter how much hardware you throw at that, it takes a while to start up these things. AWS, Heroku, DigitalOcean, anywhere where you can like host your own server code, they're going to be doing something similar to this. Your code is going to be running isolated from anyone else's code and from like AWS's code. You can't break Amazon by putting attack code into AWS because you're going to be in your isolated container or your own VM effectively. So containers. So that's the idea. VMs, containers take the idea of VMs and just make them more efficient. It's not so new anymore, but this is something that once containers came out, really took over DevOps, really took over the industry pretty quickly. And this is the way we deploy apps now, pretty much everywhere. It's hard to find an organization that doesn't deploy using containers, or at least some. No, it's containers. Whereas VMs were a bit too heavy, a bit too expensive to use. Containers are lightweight enough and easy enough to spin up that they're used all over the place. It just took over everything. So containers, the cool new thing. Yeah, Log4j had a code injection attack. In Kubernetes. So we're going to talk about Docker. There's Kubernetes and something else. I forget what it is. What is it? Ansible. So there are more ways of doing this. We'll talk about Docker and Docker Compose in this class, but there are more sophisticated, for larger deployments, for really large distributed systems with lots of containers communicating with each other. Kubernetes and others, they'll coordinate all that communication, coordinate spinning up lots of containers. This topic goes pretty deep. We'll talk about Docker and Docker Compose in this class. So when you make a change and you want to retest it with Docker, you do have to recreate the image and start a new container, unfortunately. So you typically, in this class, your workflow, actually even outside of this class, your workflow is build your app without Docker and build your features, test everything, make sure everything works. And then once you have your features working there, then run it in Docker and make sure it also works in Docker, just because it takes a while to spin up the Docker containers, rebuild the images and everything. But absolutely test in Docker in this class, before you submit, in the real world, before you deploy. Absolutely test in Docker, but it just takes a while to test if you're doing that all the time. For this, we're going to use Docker. Docker is software that you have to install. The installation process isn't too tough on Nix-based systems, on your Mac, on your Linux systems. On Windows, unfortunately, you have a little bit of extra work to do. I believe we have a Piazza post. We had one last semester. We might have to copy that over if it's not there yet. I don't know if the TAs put that on there yet. A guide to installing Docker on Windows, or Google's always your friend. Google, how do I get Docker running on Windows? You do have to do quite a few steps. You have to install the WLS, Windows Linux Subsystem, right? You have to install that and then be able to run Docker effectively in an Ubuntu install on your Windows machine. It's a little bit of a pain because it's Windows. I mean, I'll hold back my opinions, but at this stage, if you're going to be a developer, I recommend getting away from Windows if you haven't already. Windows is a great operating system for end users. It really isn't made for developers, where OS X in Linux is made with developers in mind. It gives you access to things that you'll need access to as developers, where Windows is really geared towards downloading apps and using them, playing games, browsing the internet. Windows is great for all that stuff, any end user stuff, but development, not so much. That said, there are a lot of developers who swear up and down by Windows and they love it. You know, that's fine. My opinion is it's easier to get started in OS X or Linux. And this is one case where it's just tougher setting things up in Windows. So if you have a Windows machine, just be prepared to spend quite a bit of time installing Docker. If everything goes well, it should be under an hour. But if you hit an issue, you hit a snag like I did on my desktop, my Windows desktop, it can take a while. So we're going to install Docker in dev, install Docker in production, and then Docker, we used it in both, and create identical containers in both environments. So to do this, we're going to write a Dockerfile. And Dockerfile is similar to a Makefile. If you're compiling C or C++, you have or other things, anything else you want to do. But typically that's where it's used. We create a Makefile with the build instructions. Same idea with Docker. We're going to create a Dockerfile with the build instructions that says how to build a Docker container. And let's see an example of one of those right here. So a Docker container, or a Docker image rather, is built using this Docker file. And we have specific commands, specific syntax, specific notation to be able to specify what exactly we want in our app. So this Docker file is going to spin up a node app that I'm running on app.www.js. And it's going to go through all the steps of installing things and how to get this set up. So let's go through this line by line. Yeah, do a boot with Linux. Yeah, if you don't have 1K for a Mac, installing a Linux distro is the best idea to do. Macs are expensive. That's my one complaint about Mac. Why is this so expensive? So the very first line, we're going to have from and then an existing image. So in this case, from Ubuntu 18.04, I'm going to start with an image of Ubuntu. This is going to be downloaded from Docker Central. I forget what the website is named. But it is going to be downloaded from the internet. And we're going to have a fresh install of Ubuntu. That's what we're going to start with, a fresh install of Ubuntu in a Docker container. And then we're going to start from there. So even if our entire Dockerfile is just from Ubuntu, we're going to have a container that's running Ubuntu on our machine with just one single line. But we want more than that. We want to be able to run our app. So we're going to use run commands and run anything we need to install whatever we need to get our app to run. In most cases, this is setting up the language, setting up any tools that we need, any command line tools or anything to be able to run our app. The very first thing I'm going to do is update Apt-Get, the repository, to be able to download stuff to make sure I have the latest everything set up in here. Because I don't know how old this container is or this image is. I just want to get the latest stuff from that. So run, you're going to use the run command and then use that to run anything that you would type in the command line from a fresh install of Ubuntu to be able to get everything set up. So anything you would type, okay, I have a fresh install of Ubuntu. What do I need to type to get my app running? That's what you're going to put in the run commands. So I want to update. I want to do a few things. This is optional, but I do recommend this, and I like to do it, is setting my home directory and my working directory to something that I know, in this case /root. This is going to set up my environment in Ubuntu to something where I know where to find my files. There's some default. I don't know what the default is. It might be /root for all I know. I don't know. I always override it so I know exactly where my files are going to be. They're going to be in a directory named /root. That's going to be my home directory, and that's where everything's going to be run from. How do you make a put HTTP request in the HTML side? You can send an AJAX request, or I believe you can do it right in a form. I believe you can put method equals put. I haven't tried that. We'll actually do that using, I don't know why I'm blanking on so many names today. Postman. We'll use Postman to make our put requests. That's the way I'll show you in class on Wednesday, next Wednesday. But I believe you can do it using HTML in a form, just setting the method to put. So I like doing this. You can do it or not do this. It's fine either way. But I like to do it just to be certain where all my stuff is going to be. Then if I ever have to enter into this container, I know that I'm going to be at the /root directory, and I know that all my files are going to be there. This is the same as saying cd/root. And this is saying set your environment variable named home to /root to say your home directory. And then, since this is a Node app and I have a fresh install of Ubuntu which does not include Node, I'm going to have to install Node and npm to be able to get my language running, all my language tools running on this machine. This is where you're installing whatever you need to be able to run your app. This next line, very important. We're going to copy all of the files in the current directory on your machine into the Docker image. So copy is going to take two directory paths. In Linux and Unix, dot is the current working directory. So whatever directory I'm currently in, copy from the directory that I'm currently in on my machine into the current working directory in the Docker image, which we set to /root. So it's going to copy everything from the directory containing the Docker file into /root in the image. So with this, your Docker file should be at the root of your project. So this copy ... is going to take all of your project files and put them into the Docker container. Very important to not forget that step. And we're going to install all our dependencies. If you used Node before, npm install is going to look for your requirements.json and install all of those requirements. I'm mixing Python and JavaScript there. It's package.json. It's going to read your package.json file, install all the dependencies defined in there. And it's very important to do this after you copy your files in. The order really matters here, because if you don't copy your files in, which includes your package.json, if you don't copy your files in first, there's nothing to install. There's no package.json to say what to install. So you have to copy your files in first and then install. So there's a package.json in the container, in the image at this point, to be able to actually install. We want to expose a port. Whatever port you're running your app on, we're going to expose that port, which actually ends up being optional after Friday's lecture. When we add Docker Compose to this, we'll add another layer to this. But if you're running with Docker without Docker Compose, make sure you expose that port to make sure that that port is able to be accessed from outside of the container. And then finally, run your app. Use the CMD, the command. Use command to be able to actually run your app. You should only have one command in your Docker file, and that's what's going to be ran when you run your Docker container. So most of this is going to be executed when you build a Docker image, and then when you create a container based on that image, that's when command is ran. So this isn't run when the image is being built. It's ran when the container is being ran. So just one command, it should usually be the last line in your Docker file, how to actually start your app. If you don't want to think about the difference between images and containers, one command, and that's actually starting your app, running your code, getting things going. That's a lot. There's a lot of stuff in that. Luckily, for each language that you'll use, there are pre-built containers with all the language stuff installed. So if we don't want to think about sudo apt update and installing Node and installing npm and stuff, if you want to use Node, just do from Node and then the version of Node that you want. I have 13 on the slide. And then you can skip all of the installs, all the setup, really cleans things up. So I recommend using a Docker file that looks like this. I wanted to show you from Ubuntu. So if you want to do anything that's not using one specific language, you can set that up by starting with an Ubuntu install and then setting things up yourself. If you want to use Node, from Node, I still like to set up my root stuff, my root directory. Copy your files in. npm is already installed, so you can use that to install your dependencies, expose your port, run your app. Makes things a lot cleaner, a lot simpler. Enough people use Node, for example, that it was worth somebody creating a Node image and just saying, here, everybody use this. It makes things a lot easier for everybody. For whatever language you want to use, Google's your friend, Docker, and then language. Usually you'll have 20 tutorials that pop up of how to create a Docker file for that language. Since I'm recommending Python, this is probably the one that a lot of you will end up using. From Python, and then your version number, I have 3.8 shown here. I think 3.9 is out now, right? Or even 3.10, I think. I don't remember. But your Python version, get the image for the Python version that you want. Then I do the same thing, my root directory, copy the files, install all my dependencies. We use pip and then a requirements.txt, typically in Python, to get all those requirements. Expose your port, and then these quotes are optional. I put them here, but not in my other one for what it's worth. And then command python 3 apt.py. Assuming your server file is called apt.py, might be called server.py, whatever it's called, run your app. All right, any questions on all of that? Do we need to deploy our homework on Heroku? No. I want to require deployments, and I did for 2 semesters in this class, but it's just a lot. Thank you, Toldfish. But I want to require deployments in this class just so you can see your app actually live on the internet. But there's just so many little complications with that. It really detracts from the material that I'm really trying to cover. So I will show examples. I'll deploy an app. Towards the end of the lecture, I'll deploy an app and get a domain name and get HTTPS with SSL certs and everything. I'll go through all that process and I'll show it to you. But having you do it for the homework, it's just an extra complication to be able to do that. But I'll show you how to deploy on DigitalOcean specifically. So if you do want to build an app and deploy it on the internet with a domain name with all kinds of good usability features, I will show you how to do that. If you want to know before I get to those lectures, just ask, like in office hours, I'd be happy to go through it, as long as I have time. Oh, by the way, I did post my office hours. They're right after Wednesday lectures, so right after this, in my office for 2 hours until noon. That doesn't make sense. Until 1. So once we have our Docker file, we're going to build a Docker image using this line. We'll actually talk about Docker Compose in the next lecture, and we won't end up using this unless you want to test your containers before you have Docker Compose. But this would be the command to build a Docker image, Docker build -t, whatever you want to name the image, and then a trailing dot. That's not a typo. That's very important to have that trailing dot that is specifying the directory where the Docker file can be found. The dot, just like the copy dot dot, that dot means the Docker file is in this directory that I'm currently working in. It has to be there. If you forget that dot, you're going to get errors. So that builds a Docker image. But what we're after are Docker containers. We want Docker containers. So what do we do with this image now that we have it built? This is going to run everything except your command at the end and build that image. To build a container, which if you want to think about OOP stuff, your image is like a class. Your container is like an object. We're going to use images to create containers. So we have our image now. We're going to use that to create any amount of containers that we want. And you can have multiple instances of the same app if you're so inclined. To do that, Docker run -p, specify what port you want to map to your container port, and then the name of the image that you want to build the container from. So whatever image you chose when you built the image, use that same image name when you're running a container. The -p, you're going to choose some port. For our purposes, it's going to be 8080. That's what's specified in every homework assignment. It'll always be run your app on 8080, port 8080. And then you're going to map that using a colon to whatever port your app is running inside of your container. So inside your container, you're going to have a whole set of ports that's completely separate from the ports on your actual machine, on your laptop. It's going to be a whole different set of ports. So our app's running on port 8000 in the container, and then we're going to choose some port on your laptop to map into that port. So I'm going to choose some local port. We'll typically choose 8080 in this class. And then whenever your laptop gets a request for port 8080, Docker has control of that port and will say, oh yeah, this is a message for this container's port 8000. And then it'll talk to your container's port 8000, which will end up talking to your app. So this local port for the homework has to be 8080. This internal port can be whatever you want. Unless you don't get Docker Compose running, then that should be 8080. But you're all going to get Docker Compose running. You can add a -d right here. This is going to run your app in detached mode. Run your container in detached mode. This is what we'll use for deployment when you actually deploy to production. Run in detached mode. That means it runs in the background, and it just runs forever until you stop the container, until it crashes. That's what we use in production. We typically won't use that in development because if you don't have the -d, then you actually get to see the output of your program, and you usually want to see all your print statements and stuff when you're debugging your app, when you're still building features. And then once you run this, you should be able to go to your browser, localhost 8080 or whatever you choose for local port, and your app should pop up. When you're using Docker, don't use localhost inside your app. When you have the host equals localhost, this probably should have been the lecture question actually. When you have the host equals localhost, you won't be able to access your app from outside of the container. Make sure instead of localhost, you use 0000 as your host. That's the last slide, right? All right, and see everyone Friday.